Oh, okay, we're on. We're on. Sorry about that. I kind of lost my marbles for spring break here, but anyway, in my Tommy Bahama shirt. But okay, so the exam's over. That was kind of a small train wreck. All right, and I think it's because there's a lot of nuance and momentum. Certain things, certain questions that some of you missed, that I saw quite a few missed, were like, if two objects smash into each other, the or no, here's a good one. Here's one that quite a few missed. Was no, you got that one right. But let's say there's what do airbags do? They decrease the force, not the impulse. The impulse stays the same because the momentum, the change of momentum, is still the same after during a collision. All right, and then the collision, then the momentum's saved. But whatever. This is going to be like short, like 4 segments, 7 minutes long each one. Right, because we're going to start. Your homework's going to start with chapter 9, but now we're going to do the kinematics, displacement in an angle, and how we measure displace and how we find that distance s along the outside of the circle. And I'm going to just do it. That angle is changing over time, where we let the change in displacement. It's now like a, right? Change in the angle over time is equal to the angular velocity, which is represented with little omega. All right, so that's what we're going to do. But first, we're going to get a little bit of the geometry. Yeah, here you go. You probably did these. So I wanted to do this by scale instead of freehand. I'm not going to show any slides or anything like that. So here I've got a 50-degree angle. All right, so let's just walk through this. Here's a 50-degree angle. Okay, and I have, this thing has a distance of, as a radius of 5.5 centimeters. 5.5 centimeters. I want to find out what this distance is along the edge of that circle. I want to find out what that red line distance is, which should have been the circle, but I don't have a compass that holds a pen. So there we go. I want to find out what that distance is from here, this arc of the circle to this arc of the circle. Well, you all already know this. You know that the circumference to go all the way around the circle is equal to 2 pi r. I'm going to change this angle. I'm going to make that angle into radians. Okay, and so 360 degrees is equal to 2 pi radians. So if I divide both sides by 360, I get 1 degree is equal to pi over 180 radians. Okay, and so if I have 50 degrees, I've got 50 pi over 180 radians. All right, this is all 9th grade, 10th grade stuff, right? Damn, I forgot my calculator. It's out in the thing, but that's all right. It's out in the car. But anyway, I can still do it this way. Do they got a pi key on this sucker? Yes. So I go 50 pi divided by 50 times pi divided by 180. It's 0.872. So the angle is actually equal to 0.872 radians. All right? That's what the angle is equal to. All right? Okay. So, sorry. Anyway, 0.872 radians. And so there we go. So let's change it. So we know this is 2 pi radians. So C, to go all the way around, the circle would be 2 pi times 5.5 centimeters, and whatever that comes out to be. All right, and then, but what's my angle here? My angle here is 0.872. So this distance S up here in the corner is equal to theta, the angle, times r. Well, we normally do it this way. We do it r times theta is the way we do it. Okay? So that's how we find the angle. Don't convert your calculator to radians. I don't think, we're not going to use that yet. We're not going to, when we go to springs, when we go to harmonic motion, we'll use radians, but on the calculator for the angle. But right now, we don't need to, because everything's going to be in radians that you're given. If you have to convert to degrees, that's fine. You see how that's done. It's pretty easy. Okay? It's not that hard. All right? So that's the way you do it. That's the way you convert, so the distance S is equal to R, which doesn't change, times theta. Now, what happens when we're changing? Okay, so let's stop there.